Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 10 on parallel lines in the coordinate plane. We worked a lot with parallel lines earlier in the course in what's known as the Euclidean plane. That's just, a flat surface that extends forever but doesn't have any coordinates or any grid on it. The great thing is we can also work with parallel lines in the coordinate plane, right? In a grid with an x-axis and a y-axis and coordinates and equations and all that kind of stuff. And what's really cool is that parallel lines share something with each other that's amazingly important. And once you see what it is, you can also probably say, well, that makes a lot of sense. So let's get right into that in exercise number 1. All right, here we go. Parallel lines, as we know, are defined as two or more lines that lie in the same plane, the same flat surface, that do not intersect. Now, another way of saying that they don't intersect is basically saying, look, they have no points in common, right? There's no point on one line that's also on the other line. So let's look at a situation of two parallel lines in exercise number 1. The graph below shows parallel lines M and N. Letter A asks us to write the equations of both lines in y equals mx plus b form. Awesome, right? So here we go, two parallel lines. I sure hope they look parallel to you. All right, and what I'd like you to do is something that we've done many times, which is take the graph of a line and actually write down its equation. You're going to need to figure out the slopes of both lines, the y-intercepts of both lines, and then put them all together in y equals mx plus b form. So pause the video now and try to come up with the equations of both lines. All right, well, the easiest thing about any equation of a line is identifying its y-intercept, the b value, if you will. So for line M, right, the b value is equal to 6, and the slope, right, which is the change in y over the change in x, can be found by just taking one of these points and let's go to the right 2 and let's go up 1. So it looks like the slope is 1/2, which means the equation is y equals 1/2 x plus 6. So ultimately, that's what we're looking for, right? 1/2 x plus 6. Now, for line N, same song, second verse. Right, let me just bring this up a little bit. All right. For line N, the y-intercept, is -3. I almost thought it was -4. The slope, which is the change in y over the change in x. Well, again, I can pick, let's say, this point. I'm going to go 2 to the right and 1 up. So that means the slope is 1/2. And that tells me the equation is y equals 1/2 x minus 3. All right. Now, it's probably pretty obvious, but letter B, what is the same about both lines? Well, look, a line is pretty much dictated by two things. Its y-intercept, which is where it begins, right, the B, and its slope, the M, the movement of the line. Well, obviously, they don't have the same y-intercept. One of them starts at 6, one of them starts at -3. By the way, if they had the same y-intercept, they couldn't be parallel because then they would share a point. They'd share their y-intercept. On the other hand, their slope is equal, right? The slopes of both of these lines, right, are equal. They're both equal to 1/2. And that's really the entire lesson, all right? I mean, we should just stop right now. We should just go home, right? Because the entire lesson is basically this. When two lines are parallel, they have the same slope. And when two lines have the same slope, they're parallel. And that should make a lot of sense because I think about the slope of a line as being the movement of the line, the direction of the line. If the lines have the same direction, well, then they never get closer or farther away from each other, right? For every 2 to the right, 1 up, 2 to the right, 1 up. And if both lines are doing that, then they never, ever have a chance to meet. On the other hand, if they had different slopes, then eventually they would hit each other. One of them would catch up to the other one. So let's formalize that. Here it is, parallel lines and slope. Two non-vertical lines will be parallel if and only if their slopes are equal. And again, that if and only if is a very mathy thing to say. And if and only if basically just says, hey, look, if they're parallel, they have the same slope. And if they have the same slope, they're parallel. That's it. It just basically means parallelism and slope, they just go hand in hand. The only time that they don't is when lines are vertical, but that's simply because we can't even define the slope of a vertical line. It's so steep, you know, a line that goes straight up and down, that if anything you'd have to say, well, the slope is infinity or something like that. Anyhow, let's take a look at exercise number 2. Line A has been plotted on the grid below along with the point 2, -1. Letter A, write the equation of line A in y equals mx plus b form. Awesome. Let me move this up a little bit so you can see the entire grid. Maybe move this down a bit or just rotate it around for some reason. All right, so what I'd like you to do is pause the video and try to come up with the equation of line A. Done that plenty, including in this lesson, so go for it. All right, well, the B, the beginning point, the y-intercept, that's pretty easy, is right there. So our B is equal to 7, right? In terms of our slope, right, we should automatically know that the slope is a negative slope because the line is going down. But if I sort of grab points on the line that are nice, I can grab 2 points, and I can see that if I go over 1 unit, I'll go down 2 units, over 1, down 2. So the slope, the change in y divided by the change in x, will be equal to -2 in the y, 1 in the x. We could leave it that way, but most often that'll just be written as -2. -2 divided by 1 is just -2. So at the end of the day, the equation of my line is y equals -2x plus 7. All right, so simple enough. Now, letter B, let's take a look at that. Draw a line through the point 2, -1 that is parallel to line A. Label this as line B. All right, great. So, well, how do we do that? We want to draw a line that goes through this point, but is parallel to this point. Well, the way we will do that is we will simply draw a line that goes through this point that has a slope of -2. So see if you can do that. Draw a line that goes through this point that has a slope of -2. Pause the video now and see if you can sketch that line. All right, well, let's do it. It's simple enough, right? What I want to do is I want to go to the right 1 and down 2, right 1 and down 2. I might also want to go left 1 and up 2, left 1 and up 2, right, etc. But I've got to have that slope stay a -2. If that slope is not a -2, if it turns into some other number, like +2 or 1/2 or 5 or anything like that, then what's going to happen is that these two lines are going to eventually intersect. All right, I'm going to label that line B as the directions requested. And there you go, and you can really see it, right? I hope it's pretty obvious that these two lines are parallel to each other. And again, they're parallel to each other because they're moving in the same way, right? To go from sort of one nice point to another nice point on the line, on either one of the lines, I'm going to go to the right 1 and down 2, to the right 1 and down 2. Now, the final part of this problem should be pretty easy, letter C. Write the equation of line B in y equals mx plus b form. All right, so we already know the equation of line A. It's y equals -2x plus 7. What's the equation of line B? Pause the video now and see if you can write something down. Well, we already know the slope's -2. The only question is, what's the y-intercept? Well, we can see that the y-intercept here is equal to 3. All right, so we can now say its equation is y equals -2x plus 3. Keep in mind that parallel lines, right, must have the same slope, and also they must have different y-intercepts, because if they had the same y-intercept, they would share that point, and therefore they would intersect, and therefore they wouldn't be parallel. All right? The deal with parallel lines is they must have equal slopes, and they must have different y-intercepts. All right, let's keep going. Here we go. Nice multiple choice question just to make sure you have this idea. Exercise number 3. Which of the following lines is parallel to the one whose equation is y equals 4/5 times x plus 1/2? Explain your choice. All right, so one of these 4 choices would, when graphed, be parallel to that line. Which one would it be? Pause the video right now and see if you can figure it out. All right, well, it's this simple. If 2 lines are parallel, then they must have equal slopes. So the question is, for this first line, what is its slope? Well, its slope is equal to 4/5. Choice 1 has a slope of 5/4. Choice 3 has a slope of 1/3. Choice 4 has a slope of 1/2. Looks like it's choice 2, right? There's my slope of 4/5. Right? And my explanation would be they have slopes both equal to 5/4. That's the reason, right? Sorry, not 5/4. They both have slopes equal to, my apologies, 4/5. Right? That is, by the way, a very, very common kind of multiple choice question, right? Because it's really testing 2 pieces of information. 1, do you know that parallel lines have equal slopes? And 2, can you identify the slope of a line by looking at its equation, right? Because if for some reason you thought that this 1/2 was the slope because it's a fraction, then you might think that, oh, because this line also has a slope of 1/2, it doesn't. But if you thought that the 1/2 was the slope, then you might pick these 2 lines as being parallel. That's a good question in that sense. All right, let's keep going. What happens if we try to solve a system of equations involving 2 parallel lines? Now this is really kind of cool, right? We've solved systems of equations for the last 2 days, for the last 2 lessons, right? Last lesson we solved them algebraically. The previous lesson we solved them graphically. So now, I mean, my question is, without any kind of grid, what would happen if I tried to solve a system of equations where the 2 lines were parallel? Let's explore that a bit in exercise number 4. Consider the lines whose equations are y equals 3x plus 7 and y equals 3x plus 2. Letter A, explain how you can tell that these 2 lines are parallel based on their equations. Well, that one shouldn't be that bad, especially after that last multiple choice question. Why don't you pause the video now and see if you can answer letter A. All right, well, it's this system. It's this simple. This line has a slope equal to 3. This line has a slope equal to 3. Because they have equal slopes, they must be parallel. So let's write that down. Both lines have slopes equal to 3. So because their slopes are equal, they must be parallel. All right, so, they're definitely parallel lines. But now, let's see what happens in letter B. Solve this system algebraically to determine where the 2 lines intersect. All right, now hopefully you already have a sense that something funny might happen. What I'd like you to do is do exactly what we did in the last lesson. Set the 2 equations equal, solve for the value of x. Once you have it, figure out the value of y, and see what happens when you try to solve a system of equations where the 2 lines are parallel. Pause the video now and see what happens. Well, my ardent hope is that you found something funny. So let's take a look. All right, so I'm going to do exactly what I did in the last lesson. I'm going to substitute this equation into this one, right? And I think what I'll do is maybe I'll move, the numbers over to this side, and I'll get 3x is equal to 3x minus 5. And now maybe I'll subtract a 3x from both sides. Of course, 3x minus 3x is 0. So I get this equation. Let's step back and look at this. I get this equation. I get 0 equals -5. Now, I'm pretty sure, although not entirely certain, that 0 is never equal to -5. On its best day, on its worst day, 0 and -5 aren't equal. This equation is always false. There is no value of x that can solve this equation because there is no value of x that can make 0 equal to -5. Right? This is what we called way back in Unit 1, lesson, I don't know, it was like lesson 11 or something like that. We called this an indeterminate equation, an equation that has no solutions, right? And in fact, again, we know that because this is literally impossible, right? There is no way to solve even for y. I can't even think about it. So there are no solutions to this equation. No solution to this equation whatsoever. 0 cannot be equal to -5. Now, how does that tie into what we're doing? Well, letter C, how does your answer to B support the idea that these two lines are parallel? So just for a moment, pretend we didn't know that parallel lines had equal slopes. So we knew that these lines were parallel because they both had slopes equal to 3, and we just learned that two lines that have equal slopes are parallel. But how would this kind of answer support the fact that we have two lines that are parallel? Pause the video right now and just think about this question because it's rather deep. Well, it's this simple. Right? When we're solving a system of equations, we're finding their intersection points. Because this system had no solution, it means there are no intersection points. And because there are no intersection points, it means these two lines must be parallel. Let's get that written down. All right? So the system has no solutions from B. This means the two lines never intersect. A little bit more. This means they must be parallel. I mean, can you imagine? If we had actually solved this system algebraically and we had found an intersection point, that would have been weird. Because then that would mean that two parallel lines, lines that when they extend forever should never intersect, suddenly do somewhere. But these two lines never intersect because when we try to solve them, we get a ridiculously impossible equation like 0 equals -5. Because this is impossible, there are no solutions to this equation / system, and because there are no solutions, the lines never intersect and therefore must be parallel. Isn't that kind of cool? And that will always happen. When you try to solve a system involving two parallel lines, what will eventually happen is you'll get something weird like this, like 0 equals -5 or 3 equals -2. I mean, if I had actually subtracted a 3x from the beginning, I would have ended up with 7 equals 2, right? The two y-intercepts being equal. Well, they're not equal, so not possible. All right, let's do one more problem with slope and parallel lines. And with my giant eMath instruction symbol there, the hypercube. All right, let's take a look at exercise number 5. 4 points in the plane have coordinates A, 2, 4, B, 8, 13, C, -3, -5, and D, 7, 10. A line is drawn through A and B, and a separate line is drawn through C and D. Are lines AB and CD parallel? Justify your answer. All right, well, without the coordinate grid, we can't really do this by sight. Without the equations of the two lines, we can't do them by just kind of staring at their equations. So what we now need to do is we need to go back a couple lessons when we learned how to calculate the slope of a line given 2 points that lie on that line. So what we're going to do is we're going to find the slope of line AB, we're going to find the slope of line CD, and we're going to compare them. So let's do AB together, then have you do CD on your own, and then we'll see whether or not those two slopes are equal or not. So let's do it. All right, so for AB, right, remember the slope can always be calculated as the change in y divided by the change in x, where the change in y is the subtraction of the two y coordinates, and the change in x is the subtraction of the two x coordinates. Again, for AB, I have to kind of zoom in on these 2 points, right? So I'm going to do 13 minus 4 in the numerator. That's y2 minus y1. And then in the denominator, I'll have 8 minus 2, and that's x2 minus x1. That will give me 9 in the numerator and 6 in the denominator, which I can then simplify to a slope of 3/2. All right, so that's my slope for line AB. The question is the slope of line CD the same? Is it also 3/2, in which case the two lines are parallel? Or is it different from 3/2, in which case the two lines are not parallel? Why don't you pause the video now, go through the exact same types of calculations. It's a little trickier because C is up here and D is down here, but just be careful about it and see if the two lines are parallel. Pause the video now and take a few minutes. All right, let's do CD. All right, so for line CD, again, M, I'm not going to write out the whole formula. We're just going to start doing it. I'm going to do y2 minus y1. I have to be very careful here because that's going to be 10 minus negative 5 in the numerator. And then I'm going to do x2 minus x1, and that's going to be 7 minus negative 3 in the denominator. Again, 10 minus negative 5 is the same as 10 plus 5, so that's going to be 15. 7 minus negative 3 is the same as 7 plus 3, so that's going to be 10. So without doing any kind of simplification, I find that the slope of line CD is 15/10. But I can divide both 15 and 10 by 5 to reduce this slope to 3/2. And so I can say that AB is parallel to CD because their slopes are equal. You do a lot of this kind of work when you get into high school geometry, right? And in high school geometry, you spend a lot of time trying to figure out whether figures are parallelograms or trapezoids or rectangles or squares or whatever, and you're doing it on the coordinate grid. And so what you're trying to do is you're trying to use slopes to see whether or not the sides of particular figures, like parallelograms, are actually parallel. Now, what's kind of cool about this is that you can actually see the parallelism if you plot the 4 points on a big enough grid. And that's exactly what my eMath logo here is trying to hide from you right now, is those two lines. So the line in blue is our first line, AB. The line in red is our second line, CD. They're very, very close together, right? But what you can certainly see once they're graphed is that the two lines are in fact parallel, right? They're staying the same distance apart, and they're staying the same distance apart because ultimately they move in exactly the same way with their slopes. All right, let's wrap this up. So what we saw today was a very, very important link between the coordinate grid and the greater Euclidean grid, right? We've learned about parallel lines in the past. You've been learning about them for years and years, and this idea that two lines that sit in the same plane, they go off forever and they never intersect, those lines are called parallel. What we now see after this entire unit is that we can now put a number to parallelism, right? We can say if two lines have the same slope, two different lines have the same slope, then they're going to be parallel. And if two lines have different slopes, then they're going to eventually intersect. We even saw that when we tried to solve a system of equations with two parallel lines, and we found that system had no solutions because the two lines were parallel. You'll get a lot of work with parallel lines and equal slopes as you move forward in math, as I said, especially in high school geometry. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.